I see v's on both sides of the equation. I want to get all of them to one side. I'm going to choose to subtract the 7v's off of each side. This will give me 8 minus 10v equals 14. And then we will want to get all of, subtract off this 8. Get the numbers, the constants to the right hand side. That gives us negative 10v equals positive 6. Oops, almost said negative 6. It's in the division by negative 10 that this will turn negative, and I'm going to reduce the 6 over 10 to a 3/5, negative 3/5. And you can write that negative with the numerator off to the side or with the denominator. It doesn't matter. Number 9. Again, we've got fractions, so I am going to clear the fractions by multiplying through by the least common denominator of 12. Now, should I be writing it just there? I don't know. Probably it would be better manners if you saw me physically multiplying through by 12 on each side. In this first case, or some people like to actually put a 12 next to each fraction, and the benefit of doing that is when you go to cancel, there's something to cancel with. You can actually cross them off. Here we're going to have a 4, because 3 goes into 12 4 times, and we can say 4 times that 2p makes 8p. In the next position here, 4 will cancel with the 12, making a 3, times the 1 that's there. You can kind of see the 1 through my ink. That gives me a plus 3, equals, on the right, the 6 and the 12 are going to cancel to a 2, times the 1p makes 2p, and then the 2 and the 12 will cancel, making 6, and 1 times 6 is 6. Now, some people like to write that 12 in all 4 places and cancel as I've just done. Other people just like to write a 12 off to the side and mentally do all that cancellation to keep their work neat. You choose for yourself which is going to work the best. Here we now need to get all our variables to one side. We can't solve for p's on both sides, so I'm going to choose to subtract 2p off of each side. This will give us 6p plus 3 equals 6. And now we're solving for p. We see multiplication, we see addition. We undo the addition first. We subtract 3 on each side. We're now going to have 6p on the left equals 3 on the right. And dividing by 3 on each side gives us p equals, that'll be 2p equals 1. And in the process of dividing each side by 2, we will then have, I'm going to move off to the right here, p equals 1/2. Now, to check that solution, you actually have to substitute that 1/2 in for each occurrence of p. Most people choose not to check their solutions when they've got fractions, and it's going to be messy, but that's actually the time you should be checking it more so. So I'll let you choose on your own when you're going to check these. I'm trying to keep the video time down, so I'm going to skip the check on that problem. In this next problem, we see that there's parentheses, something we haven't seen as of yet, and we probably want to get rid of them. So I'm going to distribute the 5. That will give us 10x plus 35 equals 15. And now it kind of looks like some of the problems we were doing a moment ago over there on the left. We're going to subtract 35 on each side of this equation. That will then give you 10x equals negative 20. And dividing each side by 10 will give you, or us, negative 2. So x equals negative 2, which, let's check this time. 2 times negative 2 is negative 4, plus the 7 makes 3, times the 5 out front makes 15. So that does completely check.